In today's lesson, we're going to take a look at another type of 3D shape, that is pyramids. Pyramids are very much like a prism, except that they come to a point. So instead of having two bases that are the same, they have a single base, and all those bases, when joined together, come to a point. So it could be a square-based pyramid, like the standard one, or a triangular-based pyramid, or even a circular-based pyramid, which we call a cone. Right? So the bottom has one surface, a circle, and all the edges come to a point at the top. That's kind of the key. It's very much like the cylinder, so we've taken off two chunks. In fact, 2/3 of the pyramid is of the cylinder is disappear when you turn it into a cone. It's 1/3 of what it used to be. So how do we deal with this? Well, we take that idea of it takes 3 pyramids to make one prism. Or in other words, there's one pyramid, if you have a prism, you can divide it into 3 and make one pyramid. So we're going to approach it the exact same way we did yesterday with a prism. Find your area of the base, step 1, multiply it by your height, how many of those bases you have stacked up on top of each other, but at the end we're going to divide it by 3 to make the pyramid shape instead of the prism shape. We'll give these a try. I'll start with a nice shape. Okay, the square-based pyramid. So, I got a bottom. It's a square. I got 2 dashes saying they're both 10s. How do I find my area? Well, it's a rectangle, length times width. In this case, 10 times 10, which is 100. My volume is my base times my height. So my base is 100. The height of this thing, straight up and down the middle, right here, 9 centimeters. But because this is a pyramid instead of a prism, I'm going to divide this by 3. Why? Well, again, if I make it back into the prism idea, I've lost 1, 2 of the 3 points. So that's the only difference. The exact same as yesterday, except we divide by 3 at the end. So here, I get 300 centimeters cubed. Okay, we can do the same thing with a circular-based prism, or pyramid. It's a circle. So my area is pi r squared. Did we get the radius? Yes. Halfway across is 40. And we need a calculator for this one. Pi times 40 squared comes out to 5,026 decimal 55. That's the area of the base, and we want the volume. So my volume is my base times my height. I'm going to divide it by 3. It comes to a point, we divide by 3. I'm going to keep repeating that. Okay, so 5,026.55. The height was 90. We're going to divide it all by 3 afterwards. 157.96.5 meters cubed. Okay. Common mistake that I see is people write down divide by 3, but they forget to do the divide by 3. So you can type it all in at one time, make it easier. Yeah, one little trick we have to deal with when it comes to pyramids. There are actually 2 different heights we need to worry about. And there's the vertical height, which is the height that we want, the shapes stacked up on top of each other. And it's measured from the center of the base to the point. So if we do the circle, the part down the middle, that's called my vertical height. But there's also a slant height. The slant height is the side of the base to the point. So that would be this distance here. And they're actually related to each other because of Pythagoras. If I look at this shape right here that I just drew, I draw the triangle part of it. Here's my slant height. Here's my vertical height. And the bottom, this distance right here, would be whatever your base is divided by 2, because you're only going halfway across. So sometimes you will be given the slant height when you need the vertical height, because the vertical height is the height of the shape itself. The slant height is the more the part that you see, but the vertical height is the height that we need. So let's take a look at an example here. I want to find the volume of this pyramid. So it looks just like our first example, where I had a square-based pyramid, but The blue line is pointing down the side of the pyramid. So this would be my slant height. And whenever I have a picture like this, I'm going to draw a triangle. This is 25. And the whole bottom is 14, so the part in between, this part right here, must be 7. It's kind of like the radius, right? Halfway across. And what I really need is I need the height of this triangle. So here comes Pythagoras. So I need A and B, and the important one, C. Let's give this a try. 7 squared plus B squared equals 25 squared. So B squared must be 25 squared. Numbers on one side, letters on the other, minus 7 squared. 625 minus 49 gives us 576. That's B squared. We want B, so we square root it. And B is 24. And why am I doing this? Well, I need the vertical height, right, to figure out the volume of my pyramid. So back to our question now. We got ourselves ready to do the question. What was the question? Well, let's find the volume. So to find the volume, I need my base. It happens to be a rectangle, a special one, just a square. 14 times 14 is 196. My volume is base times height. Comes to a point, so I'm going to divide by 3. So 196 times our height that we just figured out, 24. And then divide it all by 3. And I get 1,568 meters cubed. Okay, so we do this when we aren't given the vertical height, the one up and down the middle. You know you have a vertical height if you have that right angle right there. You can see it comes down to the middle. But if not, you're going to have to apply Pythagoras. The same Pythagoras you've done every time. Okay, we're going to try 2 little word problems here. Give them a try. Solid solutions make solid glass decorations in the shape of square-based pyramids, as pictured below. So here's our picture. They create a large decoration by tripling the length of each side but keeping the height the same. How much more glass is needed to completely fill the larger decoration than the smaller one? So really, we have 2 pictures. There's one we're shown, plus we're going to have another pyramid, which has, oops, that's not a square-based pyramid, that's a triangular-based pyramid. We're going to have another one that's going to be triple what we have here. But all they're doing is tripling the sides, the length of each side. So if I triple something, that means I take this, times it by 3, and I'll get 18 by 18. So we want to know the difference in how much glass is needed for each of these. So how do we do that? Well, let's talk about shape 1. Let's find its volume. Okay, I need my base, length times width, which is 6 times 6, which is 36. I need my volume, my base times my height. They gave me the height right here, up and down. That's 7 divided by 3 gives us 84 centimeters cubed. Okay, but we also have the big shape, one where they tripled the lengths but kept the height the same. So my area is still length times width, 18 times 18, which is 324. My volume is still the same formula. So 324. Our height, they said, was the same, right? Keeps the height the same. So it's still 7. And we're going to divide it all by 3. And we'll end up with 756 centimeters cubed. And what was the question? The question was, how much more glass is needed to completely fill the decoration? So the small one was 84. The big one is 756, obviously more. By how much? Let's figure it out. Let's find the difference between those. So 756 minus 84 gives us 672. Okay, the larger decoration needs 672 centimeters more glass. Okay, so just applying our thoughts, applying our definitions here, our formulas to a situation. Let's try the last one. A container that stores grain is in the shape of a cylinder and cone as shown below. How much grain can be stored in this container? So what do we have in this situation? We have ourselves a cylinder, call that 1, and a cone, call that 2. If we could figure these things out separately, we can join them together to figure out the whole thing. So let's do that. Shape 1 is my cylinder, which is a prism. I find my base, which is pi r squared, a circle. The radius is, well, it doesn't show it up here, but it does show it down here. It's the same thing, right? 3 squared comes up to 28.27. And my volume is base times height. I'm not dividing by 3 because it doesn't come to a point. It's a cylinder, a flat space. And the height is 4 right here, top to bottom. Okay, take that in, we get 113.08 meters cubed. All right, shape 2, that's the cone. And the formula for the bottom of the cone is still a circle, right? Here's my bottom of the cone this time. In fact, it's the same bottom that we had for the cylinder. They're attached to each other. The only difference is over here, for volume, I'm going to have to divide by 3. And I've got different height. And the height this time is 2. I'll divide it all by 3. And we end up with 18.85 meters cubed. And the question wasn't how big is the cone of the cylinder, though. It was how big was the whole thing. So let's take our two answers, 113.08. And we'll add it to the 18.85. And we'll get 131.93. And the silo, or the container, can hold 131.93 meters cubed of grain. Okay, there's pyramids. Pyramids are basically like prisms, except you have to divide by 3 at the end. And just to be careful, make sure you're using your vertical height. You might need to do Pythagoras. There's one question today's homework where you got a Pythagoras question, okay, that you have your vertical height and not your slanted one.